Hey, good morning, guys. So I'm hoping this will be the last video on unit conversions. So that's how we change from one unit to another unit. So we've looked at ones where we change from, let's see here, centimeters to meters, maybe inches to centimeters, and pounds to kilograms. And what I was going to look at now was maybe multiple conversions and also area, how to use area with different units. So it shouldn't be a very long video. I'm hoping to be pretty concise here. Okay, so here we go. So we're going to take a look at how to convert from, let's say, over here. Let's say you had let's go, yes, 3.5 yards. Sorry, my computer's not registering. There we go. 3.5 yards. Oh, that's weird. Mid color change. And you wanted to know how many inches is this? So there's a few things I think most, if you talk to your parents, they probably would know about yards and feet and inches. And some people do have other sort of deeper understandings of the connections between these things. But I think for a lot of people, they know the connection between feet and yards. So the connection is 1 foot equals, sorry, 3 feet equals 1 yard. So basically, you think of like a meter stick. That's how we measure in Canada, but a yardstick is actually close to a meter stick in length. Is a different size, and we can show the difference in a bit here. But 3 feet is 1 yard in the imperial system, and then in feet you can break the feet up into inches, and 1 foot. So 1 foot is equal to 12 inches. So you kind of think, I'm going to try to use my hands here. So if that was a foot, there would be 12 of these little things called inches in there. So an inch is much smaller than a foot, and a yard is 3 feet. So a yard is much more than a foot. So a foot is much smaller than a yard. So if you have 3.5 yards, well, you got quite a few feet there. And of course, if you're looking for inches, you must have lots of inches then, because remember, every 1 foot has 12 of these inches in there, and every yard has 3 feet in there. So it's a lot of feet along the way, and inches here. So I'm going to show you how to do this in 2 separate steps. But I would encourage you students that are thinking of going on to science courses, like physics physics and chemistry, to see if you can do it in 1 step and in a single step here. So I'll show you what I mean by that. Okay. So one way to do this would be, first of all, let's work with the units that relate directly to yards, because I'm starting with yards right now. So I'll say 3.5 yards. Let me just abbreviate that. And what I want to do is really go to inches. That's my goal there. But notice that neither of these conversions that I've given you here, neither of those go directly to inches right away. So I'm going to show this as 2 separate questions here. And once again, the goal here is not, like you got the right answer, good for you. The goal here is actually to show your understanding of conversion factors. So that's actually more what I'm testing you on than can you actually get from yards to inches. So looking at conversion factors, we want to look at what would we multiply the yards by to get rid of the yards. So the first thing I'm going to have to do is pick one of the conversions that has yards in it. So I'm going to use that conversion at the top there, and I'm going to write this as something over something. And so it's either going to be 3 feet over 1 yard, or it's going to be 1 yard over 3 feet. So I want to get rid of the yards, so I could put yards in the bottom, and I'm going to have to go to feet on top. And according to the numbers, it's 1 yard is 3 feet. So if we use our calculator for that, so we can grab our calculator, and we'll do 3 times 3.5. and we get 10.5. But what units would that be in? Like, how many units are we talking about? Or 10.5 miles or what? Well, let's look what cancels here. The yards are going to cancel, and that's going to leave you with feet. So this would be 10.5 feet. So now the question is, well, how many inches is it really? Like, how many? We know that 3.5 yards is the same as 10.5 feet, but how many inches is 3.5 yards? Or how many inches is 10.5 feet? So let's take our 10.5 feet, what we just figured out. And now what I'm going to use is the other conversion factor that allows me to go from feet to inches. So now I got to get my fraction set up right here. So I got to make sure I put the right units in the bottom. Otherwise, I'm going to, either multiply or divide by the wrong number. So I've got feet in the numerator on the left, so they've got to go in the denominator on the right. And then I have inches on top. And the rule is for every 1 foot, you're going to get 12 inches. And if you go 10.5 times 12 is 126 inches. Now, once again, I'm hoping most students are going to read this or watch this video. It's not so much that you went from 3.5 to 126 and just used your calculator and times that. What I'm actually trying to see if you understand is what a conversion factor is. And that's really what's going to help you with being able to do higher level science courses and also some higher level math topics and stuff that we get to. So the conversion factor is a fraction where you're trying to get rid of one unit and introduce another unit. So I wanted to show this in just a single step here, just how to do this in just one big step. And you can have multiple conversion factors. And I'll do another question that kind of relates to this. So let's say we started our beginning part, 3.5 yards. And I notice that, just going back up here again, I have two statements that are given to me about feet, yards, and inches here. And what I'm going to have to do is, first of all, get the yards out. I got to get rid of them. And so once again, just like above, I'm going to pick this first ratio here. And so in the brackets, I go yards and feet. And so basically, it looks almost like the very first step, if you look what we did here, and it's 3 feet per 1 yard. But now what I'm going to do is I'm going to multiply by a second conversion factor. And now what I want to be really careful about is how I set this one up. Now I can kind of look up because I already did this question in the question above. But what I want to look at here is just look at this line and think, well, if I do my first step, I'm going to get rid of my yards, which is going to leave me with feet. But I've got to get rid of feet because the question is really asking me to go to inches. So now I use the second statement here. And what I would say now is, well, the feet is in the numerator, so I've got to put feet in the denominator. And then I go inches. And every 1 foot is 12 inches. And now if I look at all the canceling, yards will cancel, feet will cancel, and I'm going to be left with inches, which is really what we did here. We just did it in 2 different steps. We sort of showed the steps separate from each other. And there's no reason why you can't do it that way. So if this one makes you smile and you want to do it that way, that's fine. But you might find this method is much more effective in bigger math, in more senior math and science classes, just because the number of conversion factors you're going to be working with. Okay, so I would use my calculator now. I go 3.5 multiplied by 3 multiplied by 12, and that gives me 126 inches then. Okay, so once again, I'm marking you mostly actually on this part. That is, do you actually understand how to use conversion factors? Not, can you use your calculator and times numbers together? I mean, lots of jobs require that, but a deeper understanding of conversion factors shows your understanding of how these math topics relate to, sorry, how these ratios relate to each other. So let's take a question. Let's say, right over here, just right over here, example. Let's say that you've been up in the morning and you've been awake for you are awake for let's say 3 hours. Or let's make a weird number, 3.2 hours. 3.2 hours. 3.2 hours. And someone says, how many seconds? How many seconds are you awake? Okay. So I'm going to do it this way, sort of multiple conversion factors, but you could easily do it as separate calculations if you want. So I've got to go somehow from hours to seconds. And for many of us, we don't know, you may not know what that conversion is. But why don't you think about maybe an in-between unit here, something in between these units here. And so if you think about hours, usually next I would probably think about minutes being the next smaller unit. And then from minutes, that would break down into seconds. So kind of 3 steps here, sorry, 2 steps here. So going from hours to minutes to seconds. So just like all the other questions we've done with conversion factors, write down what you're told, 3.2 hours. Use H for hours here, okay? And now I need to multiply that by a conversion factor that gets rid of the H. So let's think about 1 hour here. 1 hour, well, that's really how many minutes? 1 hour is 60 minutes. So I'm going to say 1 hour at the bottom, get rid of the hours, and go to minutes. And I might write MIN just to not think of meters here, which is what M is. And so I know 1 hour is 60 minutes. So I should times that number by 60. But now that would leave me with minutes, right? So I'm going to need another conversion factor that converts the minutes into the time unit that I really want, which is seconds here. So how many seconds are in 1 minute? Well, that would be 60 seconds. So I'm going to do another conversion factor. Now, once again, you got to remember what you're trying to get rid of. You're trying to get rid of the hours, which you did with the first conversion factor. So this conversion factor would cancel the hours out and leave you with minutes. So now you have to get rid of the minutes. So since the minutes is in the numerator, it's going to have to be in the denominator here. And that means we're going to be going to seconds. So for every, now is it every 1 second there's 60 minutes? Or is it the other way? Well, once again, go over to your statement here and you say, well, for every 1 minute, that would take 60 seconds. Okay. And now I'm going to multiply these things out. But before I do that, let's just see if it makes sense what we're doing here. Once again, remember I said that this was the part I want you to understand. So let's see if you actually understand our 2 brackets here. So the hours would cancel, the minutes would cancel, and the only time unit left I'd have is the seconds. So I'm going to get seconds here. So now I'm going to use my calculator here. So I'm going to go 3.2 multiplied by 60 multiplied by 60, or 3,600. And I'm getting 11,520 seconds. So that's how many seconds you would have been awake for if you were awake for 3.2 hours. Okay. So I think probably as far as these kind of questions go, I think I would probably do 2 steps being the most steps I would give you. But I just for the kind of super keeners in the class who might want to try something a little bit harder, I'm going to pick. Well, I won't pick one of you guys, but I'll just say I would guess if you're in grade 9, I'm going to guess you're 16 years old, okay? So let's say you're 16 years old. So how many seconds has a 16-year-old lived? And I'm gonna add a few conditions to this question because I think this could be interpreted many different ways. Let's say if you've just turned 16 years old, so you've been around for 16 years. How many seconds have you lived for? That's the first condition. The second condition is not I don't want you to mistake this as some kind of political, religious kind of spiritual type of statement here. But I'm going to assume that when you're born, so when you're first born, that's when this question is referring to. So I know people might have their own opinions on that, but I'm just going to say, let's say you're born and until you're 16 years old. How many days have you been outside of your mom? How about that? Maybe it's a better way of saying it. Okay, so let's pause the video and see if you can do that one on your own. That's quite tricky. And I'll then just restart the video and see if you have the right answer. Okay, so this one is an epic question. So you're going to say 16 years. Okay. Now the first thing I got to do is get rid of the years. So I need 1 year on the bottom. And the next smaller time unit I might think of, I mean, I could think of months, I guess, but every month, not all the months have the same number of days. So I might go to days here. Let's do days. Okay. And I'm going to be saying 365, although technically that's not true because of leap years, but I kind of wanted to avoid the fraction. So, I mean, I guess if you want to be really specific, you could say 365.25 days in 1 year. But so let's just go for 365 days per year. Okay. So if I times those numbers, my years would cancel, and now I would have days. So now I got to figure out how days is related to something in this question, and I don't know how many seconds there are in a day. That's just not something I have memorized. I mean, I could work it out, but I'm not going to say I have memorized that because that would just be weird to me. But I do know one day there's 24 hours. And I know in 1 hour from the previous question, there's 60 minutes. And I know in 1 minute, there is 60 seconds. So once again, you could do this as like 4 separate calculations, but I'm just going to show you the benefit of conversion factors that makes this math question much quicker, I think, than writing out 4 different equations. So my first conversion factor converts from years to days. So now my next conversion factor has to convert from days to hours. So I'm going to say 1 day is equal to 24 hours. Now my next conversion factor has to go from hours, so from hours to minutes. So every 1 hour, there's 60 minutes. And my next conversion factor, my last one, is going from minutes, so 1 minute, going into 60 seconds. And so let's just check our conversions to make sure things cancel out the way we want them to. So we're trying to go to seconds, but we're starting in years. So first of all, the years cancel. The days cancel, the hours cancel, the minutes cancel, and my last time unit here would be 60. So I just take my mighty calculator and I times these things out. 16 years old times 365 days per year times 24 times 60 times 60. And so I'm getting a ginormous number of 50 million not 50 million, that would be incorrect. 504,576,000 seconds. So that's how many seconds you've been around for, if you're 16 years old. Okay, so that's a pretty big calculation. I think on your test you wouldn't get one that big, but in physics you will, in chemistry you will. And so this kind of analysis is important. And once again, I know I've said this many, many times. This is what I'm marking you on. Can you multiply by a conversion factor? Not can you go from this number to that number? Okay, I mean that's sort of important too, I guess. But really, the big concept here is the conversion factors. Okay, so let's try a slightly different question. Let's say that you're looking at an area question. Let's take an area of something. Okay, and I'll use the metric system first to sort of show this. But let's say this is let's say this is 5 centimeters, and this is 4 centimeters. And someone says, what is the area of this shape? So what would the area be for this shape here? Well, area is just length times width. So I should just multiply the two numbers together. So 5 times 4. Now I've deliberately left something out of the calculation, and I really shouldn't because of the topic we're getting into. But let's just do that part of the question. So 5 times 4 would be 20. But what do you think the units would be here? Because I know 5 times, I think all of us know 5 times 4 is 20. But what units would you put here? Like, would this be miles, seconds, hours, gigabytes? So, well, let's look at the question more specifically. Let's say you included the units in the calculation. You would have 5 centimeters multiplied by 4 centimeters. So you would still get 20 if you times the numbers together. But remember in the chapter earlier, we worked with variables, and we said that if you had 5a multiplied by 4a, that would give you 20a to the power of 2. And the reason for that is that each a is being raised to the power of 1. So when you multiply like bases, you just add the exponents together. So here you've got centimeters to the power of 1. We don't usually write that 1 in. We've got centimeters to the power of 1. So it's the same kind of question. You're going to get centimeters squared. So the area is 20 centimeters squared here. And in fact, anytime you do an area question, the units are always going to be squared. You're always timesing the two numbers together here. Okay, so let's do a slightly different question. We'll keep the work there, but let's say someone said to you, what is okay, guys? Sorry, I had a little technical problem there with the audio. Kind of went crazy on me there. So let's just start playing here. Okay, so the question is, what? Hang on. There we go. So what is the area in millimeters squared? Okay, so a couple ways to do that. One is you could convert the current lengths into, so you could convert the current lengths into millimeters, and let's see here. So you could say 5 centimeters is the same as 50 millimeters, and 4 centimeters is the same as 40 millimeters because there's 10 millimeters per centimeter. And if you times those together, you would get 5 times 4, which is 20. And then you're timesing 2 tens, so you add 2 more zeros. So 2,000 millimeters times millimeters, so millimeters squared. And that's a pretty fast way to do that kind of question, converting that. But what if you didn't have the original dimensions? You were just told that the area was, say, 20 centimeters squared, and you were trying to convert that into this 2,000 millimeters. So that's what we're kind of looking at now. How would you use unit conversions to convert 20 centimeters squared into this 2,000 millimeters squared? Well, the first thing I need to deal with is getting out of centimeters. The centimeters is the units I want to get rid of. So when I use a conversion factor, I have to put those in the bottom of the fraction. So I have to sort of decide where they're going to go. And of course, the end result is I want to get millimeters squared here. So that's kind of the end goal of it, of the process. So when I look at this, I could think, well, okay, I know centimeters and millimeters, they're related to each other. So I could write a conversion factor for that, where every 1 centimeter is the same as 10 millimeters. Now, if I just did that multiplication, I wanted to show what you would get here. So if you just did centimeters squared times millimeters over centimeters, then one of the centimeters from the top would go away, and you would get rid of the centimeters on the bottom. But you still have a centimeters on top. So you'd have centimeters times millimeters, which actually is centimeters millimeters. See, yummy, yummy, yummy. Okay, so that is not looking good. So I want millimeters squared. So I got to get rid of the other centimeters. So I'm going to do the same conversion factor again. So I'm going to times it twice here. So I'm going to times it by 10 millimeters over top of 1 centimeter again. And what you'll notice now is on the bottom, you've got 2 centimeters. So that'd be centimeters squared, which will get rid of the centimeters squared on the the 20 centimeter squared part. And then you have millimeters times millimeters, which is millimeters squared. And then 20 times 10 times 10, which would give us 2,000 millimeters. Okay, so I'm just going to continue on with the video. Hopefully this narration kind of makes sense as I'm going through. So I'm kind of dubbing this in here. So let's do a different problem. I think that's what I did next, where we are converting mystery. The mystery is coming. What were we converting? I'm drawing a square. Oh yeah, there we go. Okay, so let's say the area of this rectangle is, dun, 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 what could it be? It's the anticipation. It's exciting, riveting. Ah, there we go. 3.1 yards squared. Okay, so this rectangle is 3.1 yards squared. Oh yeah, that's what it was. And let's say this was like you're trying to paint a wall, maybe your bedroom or something. Maybe put the walls in your bedroom, and you worked out the square yardage of your walls, and maybe you have to do 2 coats of paint. And you go to the store and they tell you, well, we don't know what that is in yards. We can tell you how many square feet a can of paint will cover. And so you would have to be able to convert from yards into yards squared into feet squared. So we have to have a mechanism for doing that. And so once again, we're trying to get you to show us this idea of conversion factors to convert from one unit to the other. Okay, so I'm not going to make this a question where you're actually figuring out how much paint you need, but it does have practical applications in terms of maybe your parents, for example, are going to paint your bedroom. Maybe you're old enough now to paint your bedroom. I'm not sure. It depends on what your family is comfortable with. But yeah, I think a teenager can handle a roller, but make sure they choose the right color. I probably would have painted my room black when I was a kid. That would have made my parents freak out. So send me for therapy. And here we go. So 3.1 yards squared, and I'm going to be converting this into feet squared. So I got to get rid of my yards. So I need to create a conversion factor that gets rid of the yards, but introduces the feet. And I'm going to have to do it twice, like in the previous example. So I need to have yards in the bottom, and that would have to happen twice. I'll draw a little arrow here. So I'm trying to find out how many feet squared is this? How many feet squared is this picture? So my conversion factors have to go from, have to allow me to go from yards into feet squared. Sorry, from yards squared to feet squared. Okay, so I must have been babbling about something there, but I know 1 yard equals 3 feet. Okay, so that's the conversion, or 3 feet is 1 yard. And so I'm going to put yards in the bottom twice because I got to get yards squared. So now my yards should cancel, my yards squared should cancel. And now I got to go feet per yard, feet per yard. And for every 1 yard, I get 3 feet. 1 yard is 3 feet. And now if you notice, the yard should cancel. So you have yards squared divided by yard, you're 1. And I have feet times feet. So that's going to be feet squared. So I use my calculator, 3.1 times 3 times 3. That gives me my 27.9. Yards cancel, and I'm left with feet squared in that case. Okay, so I'm going to stop the video there. I think that's where it all kind of ends. And hopefully I can splice this together and it will work for me. Please work.